There we go.
Okay. Well, welcome to the August 29th, 2023 session of Tangerine SDR and Hamside Technical Session. My name is Dave, KV0S, and this week I've been continuing to do the nightly K9Q radio builds and learning things that I thought I knew, but take more information than I had originally perceived. So let's go down the list. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. Today was the first day of classes here at the University of Scranton for the new semester. So I was busy getting ready for that. I have a digital signal processing class and a intro to foundations of physics and engineering class, and I'm heavily incentivizing my students to get involved in amateur radio and get amateur radio licenses. So we're working hard on that. I have also been working very much on the medium scale traveling atmospheric disturbance project I have with NASA and super darn data. I had some trouble getting my code to reproduce what I had published in 2016. I finally got to the bottom of that, so it's now reproducing what I had originally published. So I now know what's going on with that, which is a big relief. And so it's a lot of work getting ready for all of that. All of this has come at the expense of not answering emails. So if you send me an email and I owe you an email and you need an answer, feel free to ask me in the open session tonight. I'll try to answer it live. And otherwise, I put on my calendar 3 hours of answering emails from an undisclosed location tomorrow afternoon. So I will work on that. So back to that.
Very good. Next on the list is Dave Witten, KD0EAG. Go ahead, Dave, and welcome back to North America.
Well, hello everyone. Yeah, it's good to be back, and I've been trying to keep track of what was going on, but not much I could do from afar and answer a couple emails. But it's good to be back on the project and see everybody. That's it for me right now.
Okay. Next on the list is Jim, K4BSE. Go ahead, Jim.
Good evening. Sorry, I've been AWOL. 2 weeks ago, I was on a ship traveling down the Rhine River, and my wife and I brought back a little souvenir from the trip, COVID.
Oh.
So last week I was down with COVID.
Oh no.
So I'm just now getting back into the swing of things. I have got my magnetometer almost ready for serious measurements. I've still got to get it in the ground. Having a little trouble with that because of our fine soil here. All that clay is a little bit hard to get through. And I tried one thing and it didn't work too well. So I guess I may try a post hole digger and see if I can do any better with that. But the 3-foot deep hole is proved to be a little bit of a challenge. I'm still working on that, and I'm just about ready for the RF test as soon as the software is available. And Bill, I had a problem signing up as I was supposed to. I sent you an email a couple of days ago. I don't know if you got it or not, on the issues I was having and probably need a little bit of help getting through that little glitch. And I'm reworking the my whole grape setup now that I've got the original grape 1, the RF grape, and the magnetometer, trying to get those a little bit less sprawled out on my workbench and into one place, and hopefully I'll get that done this week too. So that's about it, and trying to get over the last of the fogginess from the COVID, not quite there, but most of the way back to net K4 BSE.
Okay, next on the list, we have Bill Engelkey, AB4EJ. Go ahead, Bill.
Oh, thanks, Dave. Good evening to the net. Most of my time has been spent frantically getting things ready for the rollout, to be ready for the eclipse, working with the Grape One, and struggling with the image. As soon as I think I've got an image ready to go, somebody comes up with some important thing that has to change it. And in true Murphy fashion, what that does is break things. So it's been a struggle here. But anyway, making progress slowly. I'm not sure that I'm going to be able to get everything that everybody wants into the image that's going to be rolled out for the October eclipse, but we're going to do our best here and see how it goes. I discovered one thing just this morning that is can be an issue for, it's a long story, but the bottom line is I may have to change the way something works that's going to affect people who are already doing some uploading. So if you're uploading, be aware I may be getting in touch with you to have a change made in the configuration. And let's see. All right, I guess that's about it from here. I would like to learn how to do the set my RX 888 to be able to push data into GNU Radio.
Okay, we dropped a little bit at the end there.
You lost your sound.
And next on the list is Bob Strickland. Go ahead, Bob.
Hello, everybody. I'm working away on this project still on as much time as I can put into it and making some progress. Got my antennas almost ready to go up and hook up some radios. So I hope to get on the air with that pretty quick. Anyway, back to you, Dave.
Very good. Next on the list is Dave McGaw, N1HAC. Go ahead, David.
Good evening, everyone. I know a number of us around here are complaining about being tired, but in my case, for a different reason. We, of course, had the Ham Exposition this past weekend, but I was triple booked, so I didn't make it to it, though we had our club there and crossed paths with Phil Erickson getting one of our AM Dopplers back. Yeah, I had a 50th high school reunion and a Scottish festival to cover. I have to say, maybe it's because we're all aging together, but I have to say our class looks pretty good for 50 years on. But been working on our KAGO project, moving that along. Our AM Dopplers, we're trying to build out to a larger network before October. We'll see, but we're having a little trouble with them calling home. I think we've changed IT people, and I know that some of the server software has changed, so it may be the same thing that Bill was just talking about. The upload protocol is somehow different. Anyway, hopefully we get that resolved. I was also interested in what Tom, I guess, was doing with the RTL-SDR on a Pi 3, because that's exactly our configuration. So I'll have to see if I can load the software that's been being worked on our system on one of ours and see how that shakes out. So other than the requisite rain coming in again this evening, we don't seem to be able to get dried out to save our life over here, but we're still standing. So Back to net.
Okay. Next on the list is Franco, K4VZ. Go ahead, Franco.
Hey, good evening, everyone. Last week I've been working with Tom McDermott to get a K9Q radio talking to GNU radio, and I think he was able to. So confirming what I was demoed last week. I'm also working. I did finish actually this weekend to work on a connector for K9Q radio, the latest version, to talk to the SDR Play RSP. So if instead of an RTL SDR, you want to use that, it should work. I'm still working on some details, but it should be almost there, the code. So hopefully should be able to work with that. And then thinking of what Bill was just saying, I'm probably going to start looking into a module to talk to the RX8A directly on GNU Radio, something that can be used as a source so people can use that. Although that will generate so much data that I don't know if GNU Radio is going to be able to provide. That'd be an interesting experiment. Other than that, we're waiting for Idalia, the next hurricane coming this way. So tonight I was starting my generator, make sure everything was fine. So we'll see how it goes the next 2 or 3 days over here in Florida. Back to Nat.
Okay, well, be careful and take care. Next on the list is Gary, AF8A. Go ahead, Gary.
Hey, good evening, everyone. Just wanted to say hello. I caught Nathaniel's comment about the new college semester and encouraging students to get licensed. Tonight, for the first time, I was working with actually a couple of very young kids showing them ham radio. One was 9, one was 10. A couple of my neighbors' grandkids. So I'm not sure that I really sparked any interest, but they say sometimes you got to strike while they're young, right? So I figured I'd give it a shot. But that's about it. Back to net.
Okay, well, good luck with that. Next on the list is Hyomin Kim, KD2 MCR. Go ahead, Hyomin.
Good evening, everyone. I have drafted the hardware X paper, which I shared with Nathaniel and Dave Witten here. So the majority of the skeleton is done, but I still need to have some details about the construction of the magnetometer, especially bill of lading. Looks like the hardware X paper requires to provide some details of how these things can be made in detail, like even like CAD files and bill of ladings. Unfortunately, the majority of the work was done by Jules Maddie, who passed away. So I don't know how much I can get, but I think I'll be looking forward to having some help from David Witten if you know some information. Otherwise, I think maybe you have to come up with some kind of solution. Maybe, I mean, it's a PVC pipe and some packaging, so it's not a rocket science, I guess. So we should be able to come up with some kind of blueprint kind of stuff, I guess. So
Well,
other than that, it's moving along. So
Is it mostly about the housing that you're looking for information, or about the board itself?
board too, I think so. I don't know how much we should provide in the paper, but based on what was written in the template, looks like, the reader should be able to sort of like copy however we did. But also we also have to declare the public domain access so that this is not copyrighted material. I think that's the philosophy of hardware X paper, I think. But yes, the packaging, the specs for cables, the board, the SparkFont board that you used. Yeah, mainly those kind of stuff. So
That's all online, isn't it, Dave?
A lot of that is on the Tangerine site. I don't know if the setup for the CAD files for the board are actually there, but I know Dave has some early versions of that.
Yeah, I have everything that went into getting it up to the point it was handed over to Scotty, but I got very little after that.
We should be able to get the we should be able to get Scotty to give us all the actual CAD files and everything.
Yeah.
You have someone who can witch him back from the dead or something.
Yes.
Yeah.
So, my plan is to provide as much as I can, given the resources that we have right now. And if they come back to us, hey, this is not sufficient, do more, then we'll do more. But otherwise, I
Yeah.
guess we don't really sweat too much.
Well, schematic and software, of course, online, and the isn't there a good write-up on the packaging?
Jules provided the information about
But
packaging.
it's online.
Where is it? It's in Hamside paper?
Yeah,
Hamside
well,
website?
it's on the Hamside website as far as
Yeah.
Yep.
pretty sure it's there. The only thing potentially missing is the layout information.
Yeah.
Right.
Scotty can supply that.
um,
And
but
it's open source, isn't it, Nathaniel?
we can
Yeah,
simplify
it
some.
it is open source, absolutely.
Yeah.
All of the hardware that we're doing is supposed to be licensed under the Tapper OHL open hardware license. And all of our software is supposed to be new GPL 3. So there shouldn't be any issues with copyright. It should all be open source.
So I'll talk to Dave offline later for some help. Yep.
Okay. Is that it?
David, you're trying to say something? You're muted.
I'll be around except for Thursday. I'll be around, but I might be in pain on Thursday, but
Sure.
I'll get over it.
Right, no problem.
I might have a copy of the structure for that casing. But the one I used was 2 inches pipe, PVC pipe.
Right.
But I have a structure how to put them together. I guess it was one of from the Tapper member. I can send it to you by email.
Okay, that's great. That'd be great. Yeah, thank you. Yep.
Sure, yes, definitely. And if you want to have, if you want to create some 3D model from that PVC, or we could just add the part number from the PVC. But if you want a 3D model, I could help you guys to create that too.
Okay.
Okay, good.
Thanks.
Is that it, Hillman? Okay. Next on the list, we have Joe, W7LUX. Go ahead, Joe.
Thank you, Dave, and good evening, everybody. Thanks to Bill, I have an up and running Grape Eclipse version receiver, and I'd like to share my screen and show a couple of the images I've grabbed off it. So how do I grab screen? Oh gosh, I always have trouble doing this. Okay, here is yeah, there we go. Here is a trace of this afternoon, nice and straight, just a little bit of deviation there. The lower image has to do with just a tuning indicator, and the upper one is actually, it takes something like 5.5 hours to go from build from the bottom up to the top. And where is my, oh gosh, there we go. Here's one that was taken yesterday morning. Another one that was taken yesterday late in the evening. I'm not sure why why it's so squiggly there. And a very colorful one that was taken Saturday morning. That's a pretty strong dawn. What do you say? Chorus here. And I'll stop sharing. Got a couple more comments. Worked with Bill quite a bit to get the configuration file right. Well, I tell you, it's got to be right dead on. And if anybody would like some help with that, I can probably answer some of the questions. I've had a lot of trouble with wall warts, noisy wall warts, particularly the ones that come with the Raspberry Pis. And they are just unbelievably noisy. Without the wall wart running, I had a nice S1 on my amateur radio receiver. Plug in the Raspberry Pi wall wart, jumps up to S7 to S8. The solution is these toroids from Pellemar Engineering. They work very well, wrap I don't know, 10, 11, 12 turns around them, and they knock that noise down very, very nicely. Let me see. Gary, I did receive the parts, so I will be working on the 2 additional grape receivers for you. And I just received an email from Turn Island Systems, and they do have filters in stock, goes from 0 to 30 megahertz. And they said something about something like $20, which seems pretty reasonable for a well-designed filter. So if anybody's interested, give them a call and see what happens. Thank you, Dave.
Very good. Next on the list is Jonathan, KC3 EEY. Go ahead, Jonathan.
Hi, everybody. I had another busy week. I ordered some parts on DigiKey. I'll be assembling some PPS Piggy boards. So the PPS Piggy is an interface board for Trimble timing receivers, from the Resolution T all the way to the Res SMT 360. They can't be used with the Res 720 unless you make a little adapter. But they're very handy and very useful, and they're great in embedded projects like VLF system kits. So I ordered 3 boards from OSH Park, and I ordered the parts, and I just wanted to make populate those 3 boards. So with my nice microscope that I bought, I plan on fully assembling them. I'm still waiting on the USB ports. It uses USB mini connectors. So that the ones that I did that were originally spec'd for that board, they went EOL, and they were replaced with a different version, different tinning, and that's on back order. That's the only part that I wasn't able to get. Also, some parts came for my RC network on the PPS input into the 3-channel VLF system. So I'm using a 125 microsecond GPS pulse per second pulse from the SMTX. And I needed parts for an RC network to shape it, so I was able to get those installed. And but I noticed something with the audio injector Octo sound card that I'm using, that Paul, the author of VLF RX Tools, also noticed. I'll share my screen here. And what you'll notice is that, so this is the RC shaped pulse. And you'll notice at the top there's some deformation of the curve. Now, this is sampling at 96K. And this only happens when I sample at 96K. When I sample at 48K, that does not happen. So it's some sort of glitching or aliasing. I'm not really sure what it is. Phil Karn, I kind of wondered what you thought thought of this, what could be causing this, possibly the digital filter of the ADD converter. It's a 6-channel or multi-channel Cirrus Logic codec, and I've raised this issue to the creator of the audio injector Octo sound card for the Raspberry Pi, and I'm also waiting on his opinion. But this is an interesting problem, but it prevents me from using this at 96K. So I could use it at 48K, but my highest frequency is only 24K for the VLF band.
Looks just like noise to me. I mean, look at the down at the baseline. Looks like exactly the same noise. It's just being added to the pulse.
Right.
I mean, is that noise at 0 present at 48?
Actually, at 48, there's a little bit less noise.
Well, okay. I mean, it looks to me like the noise is just noise. It's there all the time, and it just adds to the pulse. So
okay,
can't see it on the steep rise and fall because it's too short, but it looks to me like exactly the same noise I see down at baseline.
Okay. And at 48, that's going to be band limited.
Yeah. I mean, I don't know what the frequency of this noise is. I mean, have you grabbed it and ran it through spectral analysis and Audacity or something like that?
No, I'll have to take some recordings and run it through VT spec and see
or
what
something. Yeah.
Yeah. Yeah, because I was thinking now, there's some other screenshots that I have from Paul, and what he shows is it doesn't really look like mine, but you can see there's deformations of both low frequency sine waves and also an RC shaped pulse. And yeah, maybe that is noise that he's also seeing too, but this is kind of where I am with this. So I still have more work to do. And I also finished up my, or I finished up my EBNOT VLF transmitting rig, which uses a Raspberry Pi and audio injector stereo sound card. I finished up the case and drilling all the jacks, or the jack holes and everything else. So the only thing that I need is one of those PPS Piggy interface boards, and I could actually get this thing online and generating some VLF GPS locked signals. That's all I have for the net, that's all I have. Back to the net.
Okay. Next on the list is Majid. Go ahead, Majid.
Hey everyone. As Nathaniel said, we just started the new semester today, and the whole week I was busy with setting up labs, and I have not much for the net. Back to you.
Okay. Next on the list, I'm going to go ahead and call on Phil Harmon, BK6, a PH. Sorry, I keep wanting to put an A in it. Sorry, Phil. An old friend, somebody I talked to for about 10 years, nightly or weekly on TeamSpeak sessions. He and I collaborated on Open HPSDR for quite a while, as well as we have another person that's on here that was part of those, but he's not here tonight. So go ahead, Phil.
Thanks, Dave. And very, very nice to be able to work on SDR after a while. Unfortunately, in 2019, I became rather sick and had to stop work and SDR hobby, and I took a year to recover. But after that, while I was sick, I had an idea for a new IoT technology, and with my son, did a new startup. But doing a startup, you're so busy, you haven't got time to do anything else. But now the company's grown, I've got a bit more time, and looking forward to coming back and doing work on SDR. And especially thanks to you, Dave, but also Dave KD0VAG, who noticed me and invited me to join the group. So thanks so much, Dave. So prior to shutting down for a while, I was doing a lot of work on what I was calling direct Fourier conversion, which I know Phil K and IQ's done tremendous more work on. And I'm looking forward to getting back on and working on that technology again. So my interest at the moment, I've got an RX 888 on its way. It should be here in the next few days. And I'm interested in putting a web SDR together for my local ham club. And I gather we can use Phil's code and also PA3 FWM server code. Phil's code I can get, no problem, but I cannot find where to get the PA3 FWM code. So if anyone can point out where to do that, would be great. So having to learn a lot about SDR again, but coming up to date quickly. And again, great to be joining the club and coming up with old friends. Back to you, Dave.
Yep. I did look and it said PA you had to email him directly to get the code. And
okay,
you said you did that and he didn't reply.
I did that a long time ago because I was interested in using, I had a Hermes board which was sending raw ADC samples by Ethernet, and I was looking at using that as a web SDR, but PA3FWM never responded to my email.
Yeah. Well, that might be an interesting project to make a different version of that works with Phil's radio. We'll see.
Yeah, sending data. Well, it'll work on any of the ANM boards or the Open HPSVR boards. And the beauty was I was doing a lot of work on FPGA code because I really enjoy writing FPGA code. But there's two problems. The code was getting very large, and the compile times were just getting higher and higher. Yes. And in those days, we were using the free compiler code. And if you change one variable, it took an hour to recompile.
Right.
And the only option was to buy pay for the actual consumer professional code, which was just way too much money. And then the code wouldn't be open source. So I had to look at trimming things down, and the FPGA code to go from the ADC to Ethernet was literally just a few lines of code. And you could sample it about just over 60 megs. And using basic Ethernet and jumbo packets, you could transmit 8K of samples in one packet, get it into your PC over gigabit Ethernet, and it worked fine. But unfortunately, that's when I stopped.
Yep. Well, we have like 3 or 4 projects that are floating around here just for your information. So we have a magnetometer for space weather. We have both HF and VHF things going on. And so it may take a little bit to understand what each person's talking about. We have Nathaniel, our resident VLF person.
And Jonathan's the VLF person.
I mean, Jonathan, sorry. And so we have lots of different interests. And anyway, so welcome and please come back.
Thank you.
Next on the list is another Phil, Karn, K9Q. Go ahead, Phil.
Hey, Dave. Okay, I've been pretty busy in the last week, as Rob can attest. Let's see. Okay, I've been fixing lots of little bugs that only seem to show up when somebody else runs your code, which is, well, it's why you do this kind of stuff.
Yes.
Thanking all the people who are very patient with me. I mean, I'm not sure I'd have patience with this code if somebody else had written it. Okay, one problem that kept showing up and I didn't really know how to fix is you reboot a machine and Radio D comes up, but it doesn't seem to talk to anybody. It's running, but it's not able to do network communications. I traced that problem down to a problem I've seen elsewhere where the system starts up your program too early. A lot of programs have this problem. You say, I don't want to come up until the network is up, but then it starts you the instant that it turns the interface on before things have actually stabilized. So, the network fails. So I found a simple fix for that, which is to check for network failures and abort the program and then let system restart you 5 seconds later. And that seems to be solid. Is that right, Rob? You having any more problems with that?
It's working great. I think
Okay. Good. Okay, I did something else over the last couple of days. I don't know why I didn't do it a long time ago. I wrote a pseudo front end for KNIQ radio that simulates a signal generator. Right now, all I can do is generate wideband noise and a single tone. But those two together were plenty for me to find and fix a couple of bugs and level measurements. Had a couple of 3 dB errors here and there. So now my noise estimator seems to be working correctly. I got the actual correct value for N0. It was off by 3 dB, I think, in some modes recently. But it seems to actually give consistent answers, and I can verify that Parseval's theorem still holds. If you remember that from electrical engineering, that the integral of the signal in the time domain is equal to the integral of the signal in the frequency domain. That's a useful identity to know when you're doing DSP. Anyway, so noise estimation seems to work. I just pushed that over. I do a lot of little cosmetic cleanups all the time that I hope don't break anything. And actually, the other big thing we did just recently is I went over to KQ6RS's yesterday, Randy Stanky. He's another Qualcomm retiree like me. Randy's he's a great guy to know for RF stuff, RF transmission lines, antennas, and so forth. And anyway, he's got a FLIR camera, which is a bit pricey. And we use it to take a look at the RX888 while it was running. So let me bring up some pictures that you might like this. Okay. This was the RX888 out of the case running at only 20 megahertz. I didn't really dare to run it higher, but we were going to do some tests basically of my software to see what happens when we ran a signal generator, because he's got a good one. I don't have one. Those things are big and pricey, big or pricey or both. So anyway, this is the card just lying on the table, running at 20 megahertz with a Raspberry Pi 400, because it can't really support a very much higher sample rate than that. And as you can see, that chip gets pretty damn warm. In fact, it's hotter than the voltage regulators to the right of it. Now, after all we did is stick this little fan next to it, you see, this is what happens. So, Rob, you were absolutely right. It seems like the only way to cool this thing is with a fan, especially with these two little voltage regulators next to it. There's really no other effective way to get the heat out. They're too small, and so many, there's at least 3 discrete points here that generate a lot of heat. And to start to look like running air over it is really the only fix. So that made a surprising difference. And that fan was not even a fast one. You can barely hear it. So a little bit of airflow goes a long way, apparently.
Phil, which is the chip getting hot?
What's that?
Which
chip? Okay, that's the A to D converter right there. It has a heatsink on top of it, but its primary path, I don't think I photographed, the primary path is through a pad on the bottom and this block of thermally conductive foam to the case. And that foam was awfully thick. And all this is supposed to be thermally conductive foam. Its rated conductivity is only like 1.5 watts per meter Kelvin. I mean, it's not what I would call a great conductor of heat. Is relative only to like insulating foam that it's thermally conducting. So you want to keep that stuff thin. But that's a really thick piece because it's stuck in there between the bottom of the board and the case. And you got to tease it out of the box when you're pulling it on. It's probably ripping up that foam, which I didn't really want to do. So while I had it out, I took it over to Randy's to do all these tests before I tried to put it back together, because every time I do that, it's going to mess up that block of foam a little bit more. So we don't really see any easy way. The other problem are these two little voltage regulators right there. One is 3.3 volts, probably for the A to D, and then the other one was, what was it? 1.2. Yeah, this isn't a very good picture. We had a microscope, but it wasn't really set up for photography. We're trying to shoot through the eyepiece of the microscope. But anyway, the one on the left here, that's a 3.3. It probably feeds the A to D. This is a 1.2. It probably feeds the processor inside the Cypress chip. Now, the Cypress chip, surprisingly, did not get that hot, as you can see. I mean, it's got a processor running on it. It's handling, well, at full speed, it handles 2 gigabits of USB 3 data, but it surprisingly didn't get that hot. The real problems are these guys right here. 2 voltage regulators, which you kind of would expect, and the A to D converter. This is the VGA, variable gain amplifier. Note the transformer coupling here, so it's balanced through into the chip. And this is the attenuator. This is the Raphael micro tuner used only in VHF mode. And I'm not sure, is this the frequency reference? It's probably what it is under that shield. Because this is the little plug you use to put in 27 megahertz if you want to use an external reference. So I think that's what that is. So what's that?
That's the 5351, the one in the case.
Oh,
there.
that's the 5351, the SOX synthesizer. Is that next to the reference? Because I didn't see the reference oscillator. Is that in there too?
Yeah, I think they're all encased in there. I think Glenn opened the whole thing, and that's what he found out.
Okay, yeah, I didn't want to take it apart, but I guess that's within. I mean, where else could it be, right? Because that's the Raphael micro tuner. That you can work, but I wasn't using it either. So this is probably the low pass filter, but I can't see any of the components, so we can't figure out what it is or how it performs. That's the attenuator, which I've yet to use. I always set it 0 dB, and these are switches that switch between the output of the tuner and the attenuator. That's the variable gain amplifier and the A to D. So it's a pretty straightforward signal flow here. And of course,
so the ADC is the LTC 2208.
That's the A to D, is 2208. That's correct. It's rated for 130 megahertz, but it draws something like nominally 1.25 watts when it's running at that rate.
Okay, I mean, I've used those for years at 122.8 megs.
Oh, okay.
I never remember. In fact, I've got one here. I don't remember any of them ever getting hot. In fact, I've never put a heatsink on one. So this is one in here. That's the film. This is a PCIe interface.
Yeah.
But yeah, we use them on the open HPSDR and ANM boards, and they haven't got heatsinks. So I don't understand why that's getting so hot.
Well, it's simply a lack of airflow because it dropped very rapidly with just a little bit of air. So the problem is inside of that box, and it's not well coupled thermally to the box. It slides into the box on little slides. It's an extruded aluminum box with heat sinks on the impressive looking heat sinks on the outside, but there just isn't a very good conductor. The only conduction, the path is through that piece of thermal foam you saw on the underside of the board. There's about a 1 square centimeter pad underneath that the thing presses up against, and it's supposed to carry all that heat into the side of the box, but it doesn't do a very good job.
Okay, thank you.
Okay, so
we didn't use heat sinks on the ones that we put into the receiver that I built at Agilent either, but it had a high airflow through them.
Yeah, that airflow seems to make all the difference.
Yeah,
and it doesn't take much either. In fact, because of that heatsink there, when we did the FLIR before and after image, you can see how in this one, the 2208 is a lot cooler, but now the hottest pieces are these voltage regulators because, they're very small. They don't have heat sinks on them, so the air isn't getting out as well. So, What's interesting is Cypress chip is not that warm. Nothing else is really all that warm. The Raphael tuner is a little moderately warm, but I mean, this is the real problem up here. I mean, compared to the other stuff, that's really the big source of heat.
I know that that Robinette's been putting little fans on
Right.
the boxes in interim thing, and that they can be directly attached. I was just I didn't have a whole lot of brain power today, so I sat and fiddled with some 3D software and just looking at making a little extension to the RX-888 extrusion out of plastic that would make a nice mount to a small 1-inch fan that would direct the flow smoothly, where you want it to go, make it a little easier for people to assemble that. Somebody like Majid could probably do a better job of it than I can, but it might be something useful for some people.
Well, Randy's suggestion, it's probably as good as any, is he offered to mill a hole in the case. It's above this thing because that's the flat side, and put the fan there. I mean, there's room for a small fan to mount, flush on the side of the case, blowing air into the case, and then put some vents on the end, and put the fan right on top of that heat sink or right next to it in the regulators to push air over them. That's as probably a good idea as any. But it's clear that just a little bit of air goes a long way to removing this heat. So that confirms what Rob has found.
For this problem, I find the 2 millimeters fan with a USB power. I thought if we have two fans, one blow air in inside the box and the other one takes the air out, that makes it nice.
Do you need that much? I mean, we only have so much. I mean, we're gonna have to steal 5 volts off the USB supply, and hopefully there'll be enough.
I thought we used, one of those USB extensions from the PC, from the laptop or PC.
USB extensions. Well, it's a USB 3 cable, which I don't know how much power USB 3 can carry. I'm not assuming it's any more than the earlier USBs can carry. And this thing already draws, everything together. I'm guessing probably about 1.5 watts or 2 watts. So I don't want to draw a whole lot more power. But, a small fan, it doesn't have to turn that fast. A single fan with vents would probably be a good start. But we're going to probably give that a try and see what happens.
Well, of course, 2 watts is only 400 milliamps at 5 volts from the USB.
Yeah. Well, what's the USB rated for? I mean, you often have to use external powered hubs for some of these devices. I
think it's 1.1 amp, I think.
1 amp at 5 volts. If that's assuming your power supply can provide it, of course.
Yeah, the 888 itself draws 800 mils.
Okay.
So
how much these little fans take? Because I don't actually know.
The one I've got draws 100 milliamps.
Okay. All right. Well, it's 0.5 watt.
Might be pushing it to try to steal the 5 volts off of the 888 USB.
Does anybody happen to know that Cypress interface chip its input CMOS or LVDS?
It's CMOS. Yeah.
Okay. Because I was noticing on the 2208 data sheet that if you go LVDS, it's more power dissipation in the.
I noticed exactly the same thing. And Franco said, no, it has to be CMOS.
No, you can't. Yeah.
Okay.
Yeah. Because that's why I got the 1.25 watts figure from.
Now, I just interject, since I'm the person who I think it generated initially all the concern about the heat. I now that the software is kind of in test, I started to work on my 888s today, and I pulled one of them out, and I put it on just a full sheet of thermal, say sitting here on my desk behind me. It actually doesn't get that hot now for me. I'm not getting now when you were testing, did you have anything in contact with the bottom of the printer? Well, no. I think that I don't know if you can see it. It's in operation. I hate to pull it apart, so I don't know if you guys can see it here, but I have this big piece of thermal foam. Let's see, is that
That blue stuff.
there. Wait, hold on a second. Let me see if I move this thing near.
Oh, 1 second. Let me stop sharing here.
Yeah.
Oh, yeah. Yeah.
There,
Okay, so if I talk, maybe you guys can see this better.
yes.
How thick is that foam?
Oh, that stuff. Yeah. Same stuff.
So I'm sorry, it's like a little bit out of focus, but I just stuck this, and this is of course sitting on the on that. So with just the smallest amount of pressure, now I'm not using I'm just using a $20 infrared thermometer, but I'm right now, I think and this thing is running now at 66 megahertz at the moment, off an Orange Pi. And I've found that the hottest part is the Cypress chip, and it's about 50 C. And the ADC is, let's see, if I pull it out right now, I get, well, I've been moving it around now. If is it still running? If it's still running, now it's cooled off. I mean, it takes us. Maybe it's just because it's in the free air, but it just takes the slightest amount of. Now it's down at 40 C. You know, the chip, the tops of the chip. So I think that the slightest amount of air movement.
Yeah. So it's just lying on that foam. How thick is that foam?
It's 5 millimeters. It's the same thickness as the one that it comes with.
Okay.
So my idea was that I was gonna cut this this foam. I mean, I've got one piece of this foam from Amazon for $8. I'm going to quarter it, and that will fit a solid piece of foam underneath, you know, the back 2/3 of the board, and I'm going to slide it back in. But I don't really have I can't really, I can't measure the temperature accurately once it gets inside the case. So I don't know how much the
I was just
temperature.
thinking, we might try that again. After I put it back together, I could take it back over to Randy's and we could look in the end with the plate off. And
yeah, I can stick this thing in kind of on, point in the end. But when I take a measurement at an oblique angle, I don't seem to get very accurate temperature measurements.
Oh, well, we can look at the heat sink from the outside through the end of the box and we can see what it's doing.
Well, if you can, I tried that, and didn't get accurate, anything meaningful when I tried to shoot in the end of of an enclosure, open enclosure.
You don't have a FLIR camera though. That's just one
yeah,
spot.
I don't have it. Yeah, this is just a single spot, and so I'm not.
The FLIR camera is 128 by 128. So one thing you have to be careful about is when you have a shiny surface, it'll reflect whatever it's seeing.
Yeah.
So it reflects its surroundings if you're not careful.
Yeah. Yeah, well, I recognize I don't have the proper tools for this, but excuse me, I'm still recovering from my COVID. I still, unfortunately.
We should go ahead with the call before we finish the list.
Yeah.
Anyway,
we should go on.
Finish the list?
Right. So,
yeah, sorry.
That's
Let's go back.
all I had from this end is
I'm sorry.
stuff. Yeah.
So the next on the list was Robinette.
I should give up my time. I've already taken my time.
Yes. Okay. I just wanted, and then Tom N5EG, you're the last one on the list here. Go ahead, Tom.
Oh, okay. Did you get Franco?
Yes.
Yeah, I was earlier.
Okay. Well, it was a good week. Franco and Phil have just given tremendous amount of help this last week, and we got everything up and running. I used a Raspberry Pi 3 and an RTL SDR. My thinking was that most hams are going to have that in the junk box. They're very inexpensive, and it's a good kind of piece of test equipment to verify that everything's working. And in fact, that's kind of what it did for me, is verified everything was working. So going through building up, I've got an RTL SDR configuration file that works well now. The Raspberry Pi 3 has got reasonable loads, running about 30% load at a 48 kilosample per second IQ rate. I haven't measured it load at higher sample rates yet. The GNU radio driver seems to be working extremely well, passing Phil's latest on August 24th, fixed some buffer issues and cleaned all that up. And I'm getting clean IQ samples into GNU radio from the RTL SDR. From there, I can multiply them against a complex oscillator and shift the signals around and demodulate it with an FM demod. That all works. So it's working real well. Saturday, I took Phil's FM script and Oregon's on a 20 kilohertz FM channel plan on 2 meters. So I rewrote that, figured out where to rename all the repeaters, got all that working and demodding a bunch of FM channels. So that's working at the default 2 mega sample rate on the RTL. I didn't measure the Raspberry Pi 3's load, but it was having no problem at all dealing with it. So that's going over a switch and a router with IGMP snooping turned on. It's all working great. So I'm real happy now. And as soon as we figure out how to cool the RX-888, I'll start trying to pull IQ samples out of that. If we need a repository for configuration files or test setups or experiments or things, we might want to put one of those together. The builds I did used Franco's page on his GitHub and Phil's install.txt, and I had no issues at all with any of that. It all just came up and worked exactly. Just getting the configuration file set up correctly and getting the latest pulls of all the code seems to fix everything, and it's working real well. So it was a good week.
I'm really glad to see you working with the RTO SDR because I don't use it that much. So the driver is not that heavily exercised. So thank you.
Yeah. Well, it's just, that's what a lot of hams are going to have in the junk box.
Right.
And
the biggest problem with that device is going to be gain setting. So, if any experiences you have with getting the gains right or needs, AGC, let me know.
Okay. Yeah, I just wanted to debug the whole chain, and that helped me get there.
Thank you.
Thank you.
And let's see, did we talk to Tom?
Nope.
K7 ITM, go ahead. You talked, but I want to make sure we got everybody.
Okay.
Go ahead, Tom.
Well, I've been trying to follow my motto here. Guess you can read that if you got video. But I've been trading
I love it.
Trading some emails with Glenn Elmore about he put up a strawman receiver, and I've been poking some holes towards it. Some of them are taking, some of them maybe not, but it's really great to be talking with him because he has experience that complements mine, I would say. We're both retired Agilent. Well, I'm retired. I don't know that he actually retired from Agilent. I think he quit it. He said he quit the day that it became Agilent. But anyway, one of the things in particular that I've been doing, he has noted that he is expecting to use a calibration procedure that was patented by Agilent back, I guess, around 2003, I think the patent issued. And he says it's expired now. So I've been going through that, and I've gone through it all except for one page that's got integral signs and summations and so forth that maybe I'll wade through that too. But what I noted about the patent was it is very specifically for ping pong ADCs that are used for IF sampling to double the bandwidth that you can get from a single ADC. And the calibration procedure that's outlined in there is specifically for that and not for two aligned ADCs, time-aligned ADCs. And it actually surprises me. I went through all of the claims, and every one of them was specifically for that configuration. That surprises me because the basic idea of the calibration is applicable to simultaneously sampled ADCs, and it actually led me to thinking about some ways that it could be done probably better than what's in the patent. So that's been fun. So basically, I'm just kind of jumping in and getting my feet wet or drowning one or the other, trying to figure out just how much I'll be able to contribute to the receiver end of a project. But haven't done anything with hardware. Back to Nat.
Well, Tom, have you looked through, sorry. Have you looked through Tom McDermott's receiver design?
Nope, don't have it.
It's, Tom, can you
Yes.
tell him
Okay,
where to?
the design that we did for the Tangerine has a dual channel 14-bit A to D converter and a dual channel ADC driver. The front end is a couple of attenuators that are relay switched.
Good.
And it's set up to be, yes, I didn't want any active parts in front of the A to D converter. And then it's all differential driver through transformers into that ADD buffer amplifier. And they're on separate ground planes, which can be strapped to common ground or floated away from common ground. There's strap options so that it has some reasonable amount of common mode isolation on the two antenna inputs.
Yeah.
The converter, it's one of the more recent analog devices ones. I don't remember the name. It's an 86 something, but I think the two converters together is like 120 milliwatts or something like that. It has
very low power.
It can put out two CMOS channels, or you can program it to put out a double data rate LVDS channel. And what we do with the bits is 0 through 13 are data bits, 14 is the overflow bit, and 15 gets marked in the FPGA from the GPS PPS edge.
Okay.
So that right as the samples get clocked into the FPGA, the data word has the rising edge of the PPS set on the bit, so that they're also clocked off of the same 122.88 clock. So they should be time coherent since they're running on the exact same clock edge.
Okay, I got to ask why the odd frequency for sampling.
122.88 is the greatest common multiple of the standard sample rates related to 48 kilosamples per second.
Okay.
I remember we used 1.2288 in the CDMA, so I recognize that number.
Yeah. All the telecoms and the sound card rates and everything are all integer multiples of that rate.
So Tom, I'm trying to remember if you were here last week, which was my first visit to this group. So my background with SDR is when the 2208 first came out, I got samples of it and built a receiver. And I was very, very conscious of distortion products. So I had tried solid state switches and none of them was low enough distortion. Ended up using reed relays for fast switching because our customer wanted like microsecond level switching. And they're not as good as armature relays, but they were good enough. I actually did measure some distortion in them, and in fact, even identified that there were two distortion mechanisms.
Okay.
One of them probably is the magnetics, and the other is probably super fine point of contact with a high current density.
Okay, these are all armature relays, so
Good.
they're not fast. There's another set of relay contacts. There's a wideband noise source on the receiver that goes through some impedance matching pads. And when you flip that relay, it will inject the noise source into the front end of the receiver and switch out the receive thing. It does it through a transformer so it maintains common mode isolation. And,
Uh-huh.
so that you can have a calibrated level go into the receiver under relay control.
Right. Yeah. One of the things I've done quite a bit of work with is pseudo-random noise generation and doing things with pseudo-random noise. You could use that and then take it out at the other end.
Yeah, this is just an analog. It's a Zener diode fed from a
Yeah.
constant current source.
Right.
And it's pretty flat and wideband. The analog device chip has a lot of features built into it in the digital domain that lets you do randomization of the CMOS outputs, and you can subtract that out. I think it has dithering built in. It's got a number of pattern generators built in, which turned out to be extremely handy for testing. And those allowed us to find a bunch of connector problems on the module by, which bits were missing in the patterns and things like that. So if I can look here and try and find the part number, I've been pretty pleased with the part. It's rated about just under 12 ENOB, 12 bits ENOB. Not quite, it's 11.9 or something like that, but it wasn't very different from the 16-bit part.
Yeah, I would definitely be interested in that, Tom.
Okay, I'll see what I can find in terms of documentation.
Tom, the 2208 has both dithering and randomization, and I support both of them.
Okay.
Are they pretty common? They must be pretty common.
Yeah, I think a lot of folks do it. I'm not a real expert in that area, but it seems like if you're going to put some digital logic on the part, normally that gets done.
Yeah, I can't imagine that dithering makes much difference or sense in a radio, but it's there.
Oh, it does.
What I've seen is if there are spurious products introduced by the A to D converter, it can do a good job of knocking some of those spurious products down.
But I mean, the noise from the amplifier should be way above that.
Yeah.
So the dithered ADC, actually 14-bit, interestingly, Tom, that I did back, gosh, that's been like 25 years ago at least. I used about 10% of full-scale dithering.
10%?
Yeah, 10%. Yeah, because you're trying to linearize the ADC. And then it all gets taken out. And in my design, and it really gets taken out.
Oh, it's subtracted out in the I see.
It's subtracted out because you know what you put in. It's pseudo-random. So you know what you put in, and then X samples later, it comes out the ADC, and you take that out, and you realize, oh, well, it's spread a little bit, so it's actually in several of the samples after that, but you can take all of those out.
But with a 16-bit ADD like the 2208 being fed with an amplifier listening to HF, I mean, the noise level must be much, much higher than the quantizing noise level, I would think.
Well,
well, yes. Well, I mean, even okay. Right now, I'm looking at the LTC 2208 data sheet. AC grounded input histogram is like 20 or 30 bins wide with significant numbers. Not 30. It's a bunch of bins.
Yeah. Okay. All right.
So it dithers itself down at the low bit level, but there is some advantage to dithering much higher than that.
Well, I mean,
if you take it all out.
I'd be interested. Well, this one, I think the built-in dithering at 22.8 just does, the usual 1 bit. But I'd be curious to see if it made a difference.
I kept trying to find out what they were doing, and I never could. I guess I didn't try very hard back when I had a pretty direct line into the factory. I looked up some TI fast A to Ds, which give the A to D parts, including the LTCs, a good run for their money, I think. And they specifically said that their dither was quite low level.
Mm-hmm.
Yeah, the ones I've seen are something like 3 bits of dithering, and I've seen it knock spurious, single tone spurious components down that are maybe 10 dB above the noise level down out. You know, raise the noise floor a little bit because it wasn't subtracted out, but it completely knocks the low level tone spurious out of the
Well,
baseband.
I support anybody with a 888 and a generator who wants to look at this. I'd be curious to see the results. Also, the 888 also has the randomization feature you talked about. I don't know how much crosstalk there is from the digital pins to the analog pins based on the amount of power that thing draws just based on its output mode. I suspect it's a lot. But that also, I do support that. And it's actually surprising a little overhead. It's about 2 instructions to take it out. I economize.
Just an XOR, right?
Code. What's that?
Just an XOR.
Well, it's not quite. It's the way I do it is with a with 2 shifts and a XOR. Yeah, I shift the low order bit into the sign bit and then back, which has the back 1 less bit, which has the effect of propagating the sign bit through all the upper bits. So if it's 0, you get 0. If it's 1, you get 1 1 1 1 1 0, and then you XOR that.
Yeah.
So it's 3 instructions. And it's really fast. So, you know, I'm also curious to see if that makes a difference. I certainly can't hear anything, but if somebody wants to do some careful tests, I'd be really curious to know if it makes a difference.
Excuse me if I interject. It would be good to remember all these kind of discussions, because one thing we haven't got at this point is a proper, what do you call it? A reference document that says what our goals are with this at this point. Tom did a pretty good job with the TangerineSDR, but since we've changed, and I see this question come up, and I've kind of tried to do it, but I don't have enough information about what's possible to know what to include in a document like that. I'd like to see it written down, even if it's, you know, we monkey with it later on. It's awful good to have it up front.
Yeah.
Maybe I should include you in on the email discussions that Glenn and I are starting to have, because we're getting into that. What might we be able to do versus how much it's going to cost to do it, because we have to keep the price under control.
Well, I just like to characterize the hardware we already have. I mean, these options are already there. I just like to see what they do.
Sure. Oh.
Just when I developed the boards, the OpenHPSPR and ANM boards using the LTC228, I connected the preamp differentially permanently to the LTC208, and then an attenuator in front of the preamp, and that way putting it into random had no effect whatsoever. There was enough random noise coming out of the preamp to cause that.
Okay. The 888 has an attenuator followed by a VGA going in. And one thing I noticed while doing my measurements, I took a whole bunch of gain calibrations because I was really curious to know, you know, can I actually read dBm in my receiver? And the answer is, yeah. I was surprised for the signal strengths I get out of my radio are almost the same as the signal strength going in dBm within about 1 or 2 dB. I was really surprised. Maybe somebody designed it that way.
I'd love to see some of these, some of this thinking, you know, distilled into print at some point.
Or characters on a screen.
Yeah. Well, whatever they are these days.
I don't want paper, not in my house, not anymore.
I know, but if I know, if people can help me understand the significance of the various parameters, why we might want to pursue them, and what the cost benefit of them might be. I'd be happy to write that up. But I listen to y'all, and I can't make notes fast enough. But in the end, it would be great stuff to have documented. That seems.
Some time ago, there was an issue of the failures with the RX-888. Is that in any way related to all the heat that some of you are measuring?
That's what we were assuming. Maybe it wasn't. Maybe it had a random failure.
I think of this group, I don't know who else had a failure. I had one failure after about a week of operation. So, and I have now I have 5 more, but I've been ventilating to the 2 that I've been using. I've been ventilating with small fans, 30mm fans.
I've seen one. Yeah, I've seen one early failure that did not appear to be connected to the USB 3. So presumably it's in the RX the ADC, but that's only one, and I haven't heard of any others.
Still too many.
Yeah, in my, I mean, there are stories, but uncounted, really, unverified stories in the next generation SDR form. So, I mean, I theorized it was heat, and the symptoms suggested that there had been some desoldering on the board, that it was still the USB chip would still load software. It would appear on the USB board. Phil could load the driver software microcode into that USB that could, so all of that worked. It's just that no data came out. So that suggests that the path from the USB connector to the FX3 chip was okay, but there was somehow either the ADC went bad, or the path from the ADC to the USB was.
Well, the interesting part, Rob, was that the device code changed coming out of the
yes, which meant that you successfully loaded the microcode into the
even
FX3.
though the device code had changed. I just looked for that one too.
Yeah, the device code changed from F3 to F1, and that absolutely, and so it switched to 5 gigabit mode, USB 3 mode, and identified it itself as an RX-888. So, and I think all of that information came from a successful load of microcode from the host PC into the FX3.
Right.
So my failure mode suggested that either the ADC had gone bad, or the connection between the ADC and
have you tried running it again while pressing down on some of the parts just to see if it was?
I did try that, but the vendor agreed to take it back and give me a refund. So I decided that rather than try to diagnose the failure mode, that I try to get at least $100 out of it. Now, I'm as loath as anyone to put fans on these things, and also adding the fan makes it really awkward to how to mount the external oscillator input, the SMA for the GPSDO. So it would be, and Glenn in 6GN has emailed out the results of his test. He didn't seem to feel alarmed that the chip temperatures, the case temperatures were in the 60°C region. He didn't feel like that was such a big deal. So, I don't know what to say here. It's, I'm tempted to put, to put one together without a fan, but with a big heat thermal pad on it, and see if if that's it'll get, the chips will get warm, but I'll have a nice, mechanically nice package to for a nice combination, and maybe with some of the software changes we made over the weekend, it might be possibly even that who knows, maybe the Orange Pi could work with built-in Whisper Daemon, or maybe Jim Lill, ZKD, will get a real-time version of the operating system for the Orange Pi. He's bought 3 of the Orange Pis, so Jim seems to be highly incentivized to get a version of the software working.
I wonder if somebody makes a thermal pad with diamond dust embedded in it.
I'm sure there's all kinds of expensive solutions here, but anyway, I was gonna I thought it's so awkward putting the fans on them, unless Dave, you want to build a manifold that would fit on the end and would have space where I could mount an SMA connector and a toggle switch. That would be just great. That would be the best. That would be the best of both worlds. We'd have something that was mechanically not too awkward, and absolutely any fan, the smallest of fans, and air circulation just dramatically changes.
Not small, lowest airflow, but not physically small, please.
Oh, well, whatever. The lowest, the smallest amount of airflow was what I was meaning.
Yeah,
it is sufficient. Well, I don't know that these little the Kiwis, come with fans in them, and
they drive people nuts. I've had people.
Well, they use a cheap fan, and Clint Turner K70EI clued me into a high quality 30 millimeter fan, which fits in place of the Kiwis, and they run for years silently. So it's not necessarily. I mean, of course, there's the sound. Always going to be some sound from a moving fan, but the fan that John Siemens used in that Kiwi was the cheapest thing, and I don't think its performance should reflect on the performance of a high quality.
I would I'd love to have a stock of those fans.
Yeah, well. That's
the one I was thinking, Rob, was the thickness of that 888 is 20 millimeter. It's 21 millimeter basically. If you have not from the long side, from the short side, have attached to a small LED, to a small fan. These are 20 millimeter.
Well, yeah, some people have actually punched holes in the top of the case, mounted a fan on the top, and blew air down onto the they've been happy with that as a solution.
That's what my friend Randy was suggesting.
Yeah.
Unless you have good milling, to do any number of them, unless you have a nice CNC mill that you can do repeatedly, it's hard not to do that without making a mess, in my experience.
Well, I was gonna try to see if I could use my hole punch and reach in far enough to punch out a bunch of holes there. And I mean, it has a 2.5 inch reach, but I think the jaw may be.
It'd be hard to get that in there.
I think it'd be hard to get that. I mean, I can try it while we're sitting here, but I doubt it's going to work. So I have to loosen the screw. But yeah, I mean, I think a hole punch is a. I don't, and the top part isn't very, the case isn't all that thick. So.
No, I think CNC milling from the outside is the way to go if you can, especially if you want to do a bunch of them.
Yeah, well, that would be, no, it doesn't fit. It will, in any case, it wouldn't fit. So it's a.
I wonder if that's standard extrusion, so you could just replace the whole case.
That doesn't seem like such an awful idea.
You can find it.
Well, you're still gonna have the problem of of milling it though, because it's not going to come
Yeah.
I don't know.
No, if
Somebody
you want to do this to a lot of people, they don't have to send you their units or send you the cases. You can just send them the new case and have them do the replacement themselves.
Yeah.
Well, a lot of the Hammond cases, like the one that John Ackerman is wanting me to help him work with, have the slide out panel that, slides out and then is fairly easy to mill or even replace with a different kind of material that's easy to work.
Yeah, this is a one-piece extrusion, so
Yeah.
can't open it up.
Well, nobody here has a milling machine.
I do, but not one that I'm no artist with it.
I need someone that's
Actually, I do have one.
well, be careful what you say there. So don't volunteer to do something because everybody will pile on. But to me that would be because then you could mount the GPSDO SMA on the end next to the USB connector and a switch.
Right.
There's plenty of space for that, and then mount the fan on the top blowing down on it, and
what's the switch for?
What?
What's the switch for?
It's just so you can switch external GPSDO versus internal.
Okay.
That's
all of these ideas should go into the pot for a revised one where we actually get boards made in the future. It would seem to me.
Yeah. Well,
so I haven't heard anybody mention heat pipes yet.
Well, problem is, whatever you do, how do you get the thing into that case by sliding it in? But heat pipes are widely used in laptops. They work very well.
I guess I'm just thinking of transferring the heat to those external heat sinks that are already on the case.
Right. And that's the problem. So yeah, I mean, yeah, heat pipe was soldered to that pad underneath the A to D would help if you get the other end connected to the case when you slide it in.
Right.
Well,
some kind of flat surface with a very thin pad on it might be the way to go there.
Well, no. I think I'll do one with just the giant thermal pad and give it a try. And I don't have any way to measure the heat, but
can you actually solder the heat pipes? I never handled them.
A lot of them are copper.
Yeah, but what's inside? You won't damage them by soldering, will you?
Well, yeah, you might blow it up.
Well, that's just it. Yeah, I don't know what the word.
It's gonna suck away every bit of heat that you try to put into it to solder something.
What's the fluid inside?
Weld it. I suppose it depends on what temperature rating it has. You want something, well, at whatever pressure it's at, to be liquid where the heat sink is and vaporize when it hits the, yeah.
Right.
Could I jump in here and ask a couple of questions of Tom about his testing that he's done there on his Pi? If he's still listening.
Yeah, go
Tom
ahead,
McDermott.
Bob.
Yeah, did you built that system with version 3.10, I guess, which is what Franco's code requires. Is that right? GNU Radio 3.10.
The Raspberry Pi is not running GNU Radio. It's running the KA9Q radio program, and it multicasts out. And then on a Ubuntu 22 3.04 host. I'm running GNU Radio 3.10, and I built
Okay.
Franco's module GR RTP, and it just builds flawlessly.
Okay, so you just put Phil's code on the Raspberry Pi,
Right.
and then you're using it essentially to feed the RTP data out to the other system.
Right. Franco's module takes in, you tell it the SSRC and either the IP address or the multicast name, and it receives from that multicast stream. I actually did install KA9Q on the Ubuntu 2204 host, so I could also run the monitor utility and the control utility and some other things, but they're not strictly necessary.
Okay. Well, I have a computer here. I may try to put that together and see if it works. I can do what you did.
Yeah, the instructions on both of them worked fine. I didn't have any build issues at all.
Okay, good. Thank you.
I'm gonna say 73 for the evening. Sounds like a good discussion, like things are moving in a good direction. I do like Dave's idea of getting this written down more, and I should probably maybe try to reach out to Dave and Majid and maybe Tom and just kind of make sure we're still on track for you know, what we're trying to do with building a new piece of hardware as well. I'd really like to try to get in touch with Scotty again, to try to get those design files for the magnetometer, and try to get the see if I have not heard anything about the rework on those boards yet. So I guess I'll try giving him some calls again, and if anyone else can reach him too, that'd be really appreciated, because we really need these materials. Anyone
On the
have any?
recordings for these, do you park those somewhere where people can get to them and listen
Oh
to
yeah,
that?
if you go, usually within a day to a couple of days, depending. If you go to hamsci.org/telecons, I can put the link in the chat. It's there, and if you
Okay, great.
they're actually posted to a Hamsci YouTube channel. So if you subscribe to the YouTube channel, I think what happens when I upload the recordings, I think a notification gets sent out that a new recording has been uploaded. So
I can confirm that is the case. I keep getting those notifications.
okay, yeah.
If you
Yeah,
haven't turned on.
it usually takes me a day or so because Zoom has to process it and I have to download it and upload it and stuff like that. But I try to keep up with it. So yeah.
Thank you.
Those are really helpful.
Great. Do you want me to leave the Telecon on, or should I shut it off?
You could leave it on. I just maybe I could chat with Phil if he's still around.
Yeah.
For a minute.
Yeah,
Okay.
I'll be around for a little bit.
Yeah, that sounds great, Rob. I'll make you the host then. Thank you very much, everyone, and I will be talking to you more soon.
Good night, everyone.
Thank you.
All right.
I'm gonna check out
Good
to
night.
see you guys.
Night, Nathaniel.
I mean, anyone else can stay. I don't. You're welcome to stay on.
So I've got a quick question for Dave. You have an email address you can give me?
Me?
Yeah.
Sure. Can I put it?
I think I sent an email to the two of you. So Tom,
Oh,
you
right. You did.
It's Dave Whitten. He was
Right.
was CC. He was
Sure you
CC there,
did.
and Dave I think responded. So you should have it.
Yeah. And that's my one and only.
Okay. So okay. Any other topics here that I wanted to talk with Phil? I just wanted to get an update on what we've seen with Holger system.
Okay.
I'm sitting here monitoring it. It's been running now for, I think, close to 24 hours. And I haven't seen any, I've seen, well, I've picked up a very minor bug in my Linux user mutex code, but which I'll want to fix, but that's an easy thing. It's not disturbing anything. Just occasionally I get there's a standard error message popping into the syslog. But but I think I think we've pretty much have it working now. I'm not sure you got my latest. I had the WD record.c.
Oh, yeah, you want me to merge that? I'll do that. Sorry, I just
Yeah,
forgot.
I think I sent you one with with an exit. We were filling up the logs because I was doing a continue instead of exit on the error condition. Now, why W record lost track of, wasn't able to create a file? I think that may have been a side effect of a memory leak or something that happened as a result of it. So I think we're down to we studied. I am studying the for memory leaks at this point, and I'm not sure there's anything new here. I think that I see one of the I'm looking at VMstat and I see the buffer going up very continuously. The buffer memory.
I think that's okay. I mean, that's just holding pages from the disk, and those can be pushed out at any time when programs need more working storage.
Yeah. Well, that's I hope, and
well,
the
thing to look at for your code when you do top is the res category column. That's the resonant pages, or and then shows you just how much your program is actually using. The virtual number can go very high because that's just virtual. And an SHR is shared memory.
Yeah.
And that's shared across all of the processes, so it's not as important as libraries and such. So resonant is the part to look at.
Yeah, I was thinking if this problem reoccurs that I would go back and, because I know the process IDs of all of the components that are running. I have them, so I could write a script that went through and looked at, monitored them and says to see if they were, they were changing. We uncovered that problem with Bash. There's a bug in Bash version 5.1.4.
Yeah, I saw that you found and reported. That's good. I mean, Bash is a pretty widely used program.
And it bugs me that the Raspberry Pi Bullseye continues to use that 5.1.4. They say, well, it's because Debian hasn't updated the Bullseye version of Bash. And
Bullseye is old, right? I mean, Bookworm is now, but Debian, I mean, the Pi has not yet moved to Bookworm.
Oh well, Bullseye. They just put Bullseye out, a year ago. Took them a couple of years, between the arrival of Bullseye Debian and the Raspberry Pi Bullseye. Well, that's fine. I just tell people, don't use Bullseye with Whisper Daemon because you'll run out of memory.
But Bullseye is all that's available right now on the Pi.
No, you can go in. They offer Buster is still available. You can go.
Okay.
So it's still there, but you have to know to look for it. But it's hard to run Whisper Daemon on a Pi anymore. It's the processing required it's pretty. You can only have 8 channels or so, or 10 channels.
Well, if you didn't try to run so many copies at the same time, it might be easier.
Well, yeah, I serialized it over the weekend. I addressed that. So there is now an optional parameter where that by default I only run as many copies of Whisper D at a time as there are physical CPUs.
Right, that's what you should.
Okay, so I can't see that now. It made some difference in terms of I was seeing 1 million context switches per second on Holger's. Have you noticed that if you look at VMstat, the context switch column, normally it's switching 7,000-8,000 context switches per second.
But I'm not yet running Whisper Demon. The time has come for me to install it, but I haven't actually done it yet.
Well, it's you don't even have to. You can look at you can look at it.
I can look at Holger's system.
You can look at Holger's system. Here's the let me say cancel. Let me show you. Let me show you what I'm talking about. It's let's see where it is. Desktop here, not desktop. This one there. So no, that's not it. Well, this is gonna be I thought I was. Let's see. Where is this this window? I don't know. Here, I'll show you. Share the whole desktop. There's nothing else on it. Get this. So this is. Let's see. Okay. So this is top running up here.
Yeah.
Okay. This is VMstat. Now what I'm doing is I'm running a VMstat in the background. So the top part is where it started. I started it yesterday.
Yeah.
And these last 3 lines are the current, most recent 3 samples of VMstat.
Okay. I don't see any obvious signs of memory leakage.
Well, you see, buff started there. It's up here, and it's almost monotonically increasing. This value, buff value. Maybe that's normal.
I think that's normal. I think that's normal.
You think that's okay? Well, that's fine. Yeah. If that's fine,
it tries to use all of available memory for pages from the disk.
Well, that's okay. I don't see a lot of, I do see some block in, block out stuff. I don't know why that's
the thing to look for is on the top window. You see where, Radio D, of course, is at the top. But you see the columns vert, res, sure.
Yeah, I see vert, res.
Those are the numbers to look at. If the res number starts climbing up, you got a problem.
Well, I don't see. Can I sort by res? I don't know if I can. I'm not sure if that's.
Well, it's right now it's sorting by activity, but
yes, I know. I don't. In any case, we don't have to.
Chances are, if something is running away, gobbling up memory, it'll be near the top anyway.
Yeah. Well, eventually it'll be near the top. And I don't see that happening.
But that's the resonant set size of that program in K.
Yeah.
Kilobytes. Well, so right now, Radio D is taking up about 77, 78 megabytes, which is not bad.
Yeah.
All by Python 3.
Yeah. Well, and
as long as those numbers aren't climbing, you're okay. I don't think you got a memory leak. I don't see any obvious symptoms of one.
Well, that's good. This over here and some other we see down here is the syslog window. Yeah. This is tailing on syslog. Nothing happening there.
Do you look at the kernel log occasionally?
No, I've never quite understand what I get out of a D message. You mean?
Well, I'd show you a whole bunch of seg faults in
I know you did. I know you did, but I didn't.
You probably didn't know about, right? What's seg faulting?
Well, I think that was because it was. That's the wrong machine.
I don't know where it was seg faulting somewhere in the C library, but probably because it was past.
I think it was completely out of memory. I don't think that was a.
It could be that, for example, malloc failed.
Yeah, well, but let's see. Yeah.
And a lot of people don't check malloc, right? Because it never fails anymore, except when it does.
Yeah.
So,
well, this is D message. This doesn't. I mean, I don't.
Okay, things look fine there. I don't see any problems.
And this is basically a cat of some kernel log.
Yeah, there's an internal circular queue that's used for printf messages inside the kernel. I think it also gets copied out to verilog kernel.log. I think you can see it there too. But this is handy, like at startup, if some device doesn't detach.
Okay.
You've got disk errors or that stuff like that. That's where it will show up first.
Oh, look at this one. Perf interrupt took too long.
I see those occasionally.
Yeah,
I don't know exactly what that says, but
okay. Well, I mean, I don't think that I don't think there's anything. It doesn't look like there's anything pathological here.
No.
This window is the list of all of the the WD record jobs that are running, and
right.
So there should be 2 for each frequency.
And
this
you
is
do, and
22.
you have them. Yep.
And it's like, so basically, I was, before I was seeing a whole list of them when I hit that, when I executed a continue and WD record instead of exit. So
Yeah.
and I think that's when we were running out of memory and we got all the kernel log
Yeah.
stuff. Now
Yeah,
that
those won't consume a lot of CPU. Those
Yeah.
will write disk, but they won't consume CPU
Yeah.
very much.
So that's not happening anymore. This is the log of the uploads. You can see this is, this is the daemon that uploads to WhisperNet, and
Right.
so you can see that he's uploading blocks of 50 to 70 spots each 2-minute cycle. But
Yeah.
that's pretty normal for his site. It's he's
right.
So to me this looks like a healthy machine.
Yeah, it does.
And so I think that with the one check-in, let's see if I have this in 9Q. See, git pull. Okay, there's
I've been busy. Yeah.
You've been really busy with sig_gen, especially.
Yeah. Well, that I should have done a long time ago. God, it just revealed so many little 3dB errors and stuff. Yeah.
Okay. So this is what I have, and here, this is what I think I believe I emailed you these changes. There's 3 lines. So
yeah,
if
my
should see,
apologies. I need to pull it over.
so if you would look at the file, be sure I sent you the right file. But you should see 3. You should see 3 exit statements here.
Yeah.
I mean this.
That's so it'll get restarted by systemd, right?
Yeah, no, it'll be restarted by this is called by Whisper Daemon. So Whisper Daemon will restart.
Oh, somebody will restart it. Okay.
Yeah, this will get restarted. I would expect. I don't see any of those. The Whisper Daemon log doesn't show me any of those errors occurring. So I don't see that as occurring anymore. So I'm thinking that this system was just got itself into a kind of pathological state, and I did a reboot of it yesterday afternoon, our time, and then started up with these fixes in, and it's been and I also made the change of limiting the number of CPU cycles. So it's a configurable variable. I put in a recording decode for a CPU. So if this is defined, then Whisper Daemon looks at the total number of physical CPUs and only runs the number of CPUs minus 2. So in this case, there's I think he has 6 CPUs on this thing. Let's say QA.
Okay, it's good. Because I'm going to use a couple pretty much all the time.
Yeah, well, I thought that it makes sense. So there's a total number of 6. I figured you'd be using 2 of them all the time, so I would ensure that at least 2 were always free. Now, one other consideration would be, would there be any benefit to trying out processor affinity? In other words, to avoid.
The main reason to do that is so that you don't flush the level 2 cache quite as much.
That's
per CPU.
Yeah, and that's why I was thinking of it. If you look at the these, let's see. Let me look at VM.
Well, does the machine have a level 2 CPU cache?
Oh yes, yeah.
Okay.
In fact,
some don't. I mean, some just have like a level 3 that's shared. So
these have a level 1 and 2. In fact, I learned all of these. Let's see, is there CPU? I forget what. I found a number of utilities for looking at. No, it's not. I don't remember them now. They're maybe in the history, but I found a set of commands that I never knew about before. That show about this, tell you about the all the CPU information, but I've forgotten them already.
When it comes to performance, I mean, it's so counterintuitive these days. The only way to find out is to try it. Yeah.
Well, I don't, again, I could also, assign, processor. I mean, if we between you and me, if we were to decide on which CPUs we wanted to tack our programs to.
Well, remember the kernel already tries to do some of this. I mean, the kernel doesn't gratuitously move you from one CPU to another, but it can help it.
Yeah. Well,
but you don't want to block waiting for one CPU when there's another one that's idle. You don't want that either.
Yeah. Well, that's I'm not I'm not trying to inform. Well, this is BTOP here. Let's see. And
all I can say is try it.
Yeah. Well, it would be kind of you and I would have to agree on something, to communicate which processor CPUs we wanted to use.
Yeah, I'm not sure it's worth that.
I think my sense is it's just we're buying a lot of trouble for maybe just a little tweak in performance.
And the kernel usually knows more than you do about what's going on.
That's what I said. So here's the but I wanted final thing I wanted to show you is just if you look at here's the full log since yesterday. So if you look down here, here's 500,000 contact switches per second.
Yeah, it's a lot of them.
Seems like a whole lot to me. It was before I limited the CPUs to 4. It was over 1 million per second.
Yeah.
So
at least you have some idle time.
Yeah. Well, yes, yes. Well, that's you can see. There's, now that I'm living it, there's I think almost no time when there isn't some idle CPU time. So it seems like even when you're doing 500,000 context,
it would be nice to know why are these context switches occurring? Are they occurring because a program is blocking an I/O, or is it occurring because they hit the end of a time slice and the CPU is talking about problem scheduling? Which is it?
Well, my guess would be that your stuff is ready all the time, almost all the time. And
no. I mean, I got to wait for stuff from the A to D, right?
Yeah, but that must come in every 20 milliseconds?
Well, if it was, I would be running 100%, but I'm not.
Well, anyway, these context switches occur when there are, when decoding is running. So as you would expect.
Okay, well, decoding is CPU intensive, right?
Yes, it's completely, there's almost no I/O.
Okay, in that case, you really do not want to have too many of them running, because if you're just round robining a whole bunch of those in parallel, you'd be much better off running them one at a time.
Yeah, well,
the reasons I've already explained.
Okay, yeah, well, that's what they're doing now. They say I'm only running 4. So and there's six cores.
Yeah.
So I don't know that I can do more at the user level to reduce the this content. This seems like it looks like the context switching is chewing up in 10% or more of the CPU cycles. I mean,
look at the system. Look at the system.
If you look at the change in the system, thing looks like it's that the context switches are just burning up a whole bunch of
either that or doing a lot of I/O. A lot of paging, a lot of I/O, but I don't know what your program is doing. Probably not.
Well, Whisper Daemon doesn't. It does very little I/O. So it's
there's some kind of thrashing going on.
That's what we're trying to figure out.
Yeah.
I mean, some kind of data thrash.
That's exactly what we're trying to figure out, and that's why I keep telling Rob that too much parallelism is a bad thing.
Yeah. Well, so that's by serializing the decoding. I'm having only 4 decoding jobs running at once, at most. Then that guarantees that at least Whisper Daemon is not is leaving 2 of the 6 cores free for other things at all times.
Yeah, remember that algorithm does not run well on modern CPUs. A lot of pipeline stalls if it's using my Fano decoder. I mean, well, actually, I think all sequential decoders have this problem. A lot of pipeline stalls. It does not run well on modern CPUs.
Yeah.
Oh, did you see my note last night about how I switched the random number algorithm I'm using?
Yes.
Less efficient one because it runs faster.
Yeah, because you're doing sines or sine, cosine.
Sine and cosine is actually cheaper when I don't have to branch all the time.
Yeah.
funny about that, right? The only way to find out is to try things.
I think so. Okay. Well, those are the questions that, observations I had for you. Let's see, go back here. Yeah, you can see here's the strip chart for BTOP, and you can see how it's ragged up here when each 2 minutes it gets ragged when the 4 decode jobs are running. But it never it never actually peaks. It gets up near 90%, 90-95%, but it never. I don't think it, who knows instantaneously, but over the sample periods, I've never seen 100%. So how does that?
Well, as long as this machine's stable now, you're not running those problems anymore. Then
there we go. We're popping up.
Gravy.
Now we're running the decode jobs are running, and you can see there's a lot of variability because I'm doing the mutex in a semaphore at a user in Linux user space. So I'm polling this mutex flag directory every second.
That's one of several ways to do them. Yeah.
I didn't know of other ways at the user level.
There's explicit file locking. The problem with that is there seem to be several ways to do it, and I'm not sure all flavors of Unix do that.
Yeah.
So.
Yeah.
But like you said, Maker is an atomic operation, so it's portable.
Yeah, I read about F-locks and so on, but I thought, Mector seems to be pretty universal. So that's what I. So anyway, there's actually a little race conditioning is still inside that, but it's not that's the one that's producing the syslog, the error messages. But that's in my code. It's not in yours. But if you would check in my WD record. Let me know. Let me check to make sure that I got what
is anybody maintaining WhisperD anymore?
It's part of each release of JTX. Of JTX.
Is anybody actually maintaining? I mean, I looked at the code, and to be perfectly honest with you, I did look very bulletproof, put it that way.
I think Steve Franke was responsible for it. Professor Steve Franke at the University of Illinois. And I think he's been focused on other things to the extent.
I understand.
And so,
I mean, if it really mattered, I could go through and at least harden it a little bit. I just don't want to duplicate somebody else's effort.
Nobody. I would encourage you to do it because what would be a tremendous benefit? It would be, of course, a tremendous benefit to make it more CPU efficient. But if you could use, I haven't seen any progress from Ryan on outputting a spreading number. Like we get spectral spreading from the JT9 decoder. We don't get it from WhisperD, and the information is there.
It does give what, a frequency offset estimate?
What it gives is the band of frequency bins, the width and frequency bins of I think 50%, or the cumulative 75% power spectrum.
Well, what are you looking for?
Well, it gives us, it's what we use to look at Doppler shift in essence off of the whisper.
What don't you have that you want?
I'm sorry.
What don't you have that you want?
It does. The JT9 that decodes the 4W packets. Okay, it has an option to turn on and output the spreading numbers from it gets for each.
But you're saying WhisperD does not.
WhisperD does not. All it outputs is the spots. Okay. And the information is generated by the FFT performed by WhisperD.
Right.
But they don't output the calculator output those values.
Okay.
So having that value would be a tremendous contribution, I think, to the research community, because now all of the whisper signals become candidates for Doppler shift measurements.
Right. I'm trying to. Okay, there's a bunch of numbers that come out of WhisperD, and I haven't looked at what they all are. I mean, one is like the time offset.
Yes, there's if you look at the let's see if we if we go here, we can look at a Control C. Hold on a second. Okay. If you look at, let's see, is it in this directory? Wrong place. If you look at it, well, we can go down and just look at an all whisper. Whisper.
I can look at mine. I run it too, but
Yeah. Well, if you look at the all whisper.txt file.
Right. That's what I'm talking about. Yeah, those numbers.
Okay. Yeah, those numbers I went through and I document them. They're documented what they mean in all of the in Whisper Demons code, because I took a look at their JTX code and parsed out what they were printing.
Right.
But
it's not well commented.
It's poorly commented. I tried to do a better job. This is, of course, the SNR value.
Right.
This is the I think the offset time. Okay.
Okay.
This is a time from second zero. Of course,
Right.
This is the frequency.
Right.
This is a variable length field. There's because there are three different types of whisper packets.
Right.
So that some of these here's one that has only a hash. This is a type 3 packet.
And it looked the hash up in the dictionary. Yeah. I know that.
Yeah. And the rest of these are kind of internal things.
Yeah, that's what I was wondering about, whether any of those were of interest to you.
No, they're not of interest. They don't really, we don't understand what they mean. But I actually, because I don't understand what they mean, I end up recording all of them in our database. I mean,
yeah, I think some of them have to do with decoder metrics and decoder moves.
There's things
stuff
called
that I know, but I did a long time ago.
Yeah. Well, there are things called metrics and so on, and I do document what they mean. They're not really important to us. It just
they're there for tuning the decoder.
Yes, and I wouldn't be able to. But not knowing anything about the internals of it. One of the things we did in implementing Whisper Daemon is record all of the information that comes out of in all the all Whisper text. And one of the things is, you see, the decoded frequencies come out with 1/10 of a hertz accuracy or resolution.
Probably not real. Well, actually, is that real?
No, they're real. That's a real.
Okay, that's real.
Those are real. Those are real. Those are real, and they are. If your receiver is GPS-DO, as this one is, then
it should be real. Okay.
Yeah, these are real to 1/10 of a hertz, but
Okay.
you don't know how much. The Whisper decoder compensates for drift, and in fact,
right.
There is. Let's see. This column is the drift number, which is rather crude. One that says this guy was drifting down by 1 hertz over the 2-minute period.
So it's looking for chirping. Okay.
So in contrast to JT9, which doesn't compensate for drift, Whisper D does compensate for drift, which is one of the reasons I thought it might be a lot more CPU intensive, because it has to kind of I presume it goes multiple passes making guesses for drift values. I don't know. But
well, it's important to know that. I mean, it's an FSK scheme. It's very slow, so drift is important.
Yeah. Well, we don't really care. Of course, we don't really care if a transmitter is drifting. Then it's not going to be very useful for Doppler shift.
Well, how do you know it's the transmitter, not the ionosphere?
Well, that's the problem. Is we know we have a known set of good 4W transmitters, and we know that they're using a GPS-DO.
Yeah.
We don't know on the in the Whisper world, but we do have receivers, GPS Whisper Daemon GPS disciplined receivers around the world. So if we had the way to measure the spreading values, if one or more Whisper Daemon GPS-DO sites says, hey, this Whisper signal has a low spreading value, a low drift, then we could tag him and put that transmitter on a Weiss list and say, this guy is a good candidate as a a stable transmitter, and we could where the transmitter itself is stable enough that you can make Doppler shift measurements from him. So
assuming he stays stable, yeah.
Yeah, well, yeah, it depends on how much you. I mean that the drift numbers we do see are remarkably low at times. I mean, during the daytime on 20 meters, you can get ionospheric drift of less than 4 millihertz.
Oh.
I mean, I don't think Joe Taylor or any of the guys ever thought that was possible, and that's why they don't include 4W on any of their by default in any of the 4W bands, are not by default. The only bands that they set up in their release of JTX, the only bands that are set up for 4W are the 2200, 630, and 160.
Yeah.
But so that reflects the fact, as Joe stated in his little treatise on 4W, is he didn't think that 4W, that the spreading of at higher bands would be so great as to render 4W not useful.
Yeah, well,
and not
that's why I
decodable.
experiment, yeah.
But it's not. But it turns out that's not true. That in fact it's remarkably stable and remarkably useful. Not so much on 80 and 40. There's so much multipath, and until we can get rid of the multipath, it can't.
Yeah.
Okay. Another project. But if you look at 20 meters, when there isn't multipath, and you can actually tell when there's multipath problems on 20 meters, typically at morning and evening. But if there's no multipath problems, during the daytime, the ionosphere is remarkably stable most of the time.
I noticed that. Yeah, I mean, looking at like CB a while ago, I mean, the coherence times are remarkably long.
Yeah.
Yeah.
So it would be a wonderful contribution to do two things. There's one other element in the that could be done in a revision of the Whisper D decoder. One would be to the one I've just described, to output the spreading number. And the second one would be to output a deconvoluted version, where you once you decode a carrier, you know what tones it's putting out. Okay, subtract that to the offset from the frequency, and you now have kind of generated a pseudo CW carrier.
Right.
And so from that you could use all of these 3,000 Whisper beacons transmitting are candidates for WDBE kind of monitoring.
Yeah.
Because that even though they're modulated, exactly what they're very closely with, certainly
Right.
apart from the transitions, when tone transitions happen,
Yeah.
what tones they've chosen. So if those numbers could be output as part of a Whisper D
Strip
decode.
off the modulation. Yeah, we did a similar trick when we did we wanted to make GPS work indoors. At much lower signal strengths. The only way to do that is to make it you have to integrate over longer periods of time. Well, you do that by sending the navigation message over the cellular channel, so you already know what it's sending. You can strip it off before you carrier, and then you integrate that carrier over longer periods of time than 20 milliseconds, which is the usual bit time. The navigation that's in GPS is 50 bits per second, so each bit is 20 milliseconds long. So you can normally only integrate for 20 milliseconds, but if you can strip off the message, then you can integrate as long as you want.
Well, that's anyway. Well, there you have
Same idea.
there you have my two ideas I have for enhancing Whisper D, but they require skills that I don't have. And but
I was thinking more about just going through and just hardening things like checking for error returns from malloc.
I know, but but I don't think that I don't think that justifies the. I mean, most of these people are running JTX. They're only decoding one band at a time. So they're running even if they're running a puny CPU,
No.
You'll see some of them. The JTX, the message ends at second 109 or something. Or I'm sorry, 111. It ends at second 111. You'll see them posting up their decoded spots 2 or 3 seconds later.
Yeah, I'm sure.
No, that because they've got one CPU, they're working on one band, they've probably got an i7 or i9. Bam,
And
it
if the
runs
signal
through.
is strong, it decodes quickly.
It decodes quickly, and bam, they post it up.
Right.
And so I don't do that in WhisperDeem. I wait for all of the decodes to happen, and of course I'm doing, here on this system we're looking at, we're doing 30 decodes every 2 minutes, and
Yeah.
so there's no, it takes 10, 20, sometimes on some CPU store systems can take 90 seconds before they finish all their decodes.
Mm-hmm.
So it doesn't make, it just means that their decodes arrive late, but who cares if they arrive 30 seconds later? There's no contest between how quickly you can get your spots up, I think, is kind of a foolish contest. But
They
anyway,
say contest, some ham, whatever it is, some can.
yeah, that'd be ham. That'd be hams. Well, and there are the my guys like Tom, who are really kind of driven to be a top of the top spotters sheet. Have you?
Right.
You've seen Phil's top spotters page. Are you familiar with that?
No, but I go.
Well, it's in a whisper.live. If you're ever going to look at, I'm sorry, the wrong one, whisper.rocks. This is Phil VK7JJ's type, and he's got a top spotters page, and this tells you who's received the most. This is sorted in the last 24 hours. Well, actually, this is the last 24 hours. Who's spotted? Well, you can sort. He sorts by unique call signs. There's a total of about 2,600, 2,900 beacons on active.
Yeah.
So this is John, a friend who's in the Canary Islands, and he's got a location that just can't be beat for receiving anyway. This is Frank. These are all running Whisper Demon. This is Tom Paratori.
I recognize that.
So he's the one who has the
OE9 GHV number 6. Yeah.
Yeah. So this is, I don't know this guy well, but here's Holger, and here's Holger's Q. Here's our
GM0 UDL. Okay. All right.
Yeah, UDL. That's UDL.
I recognize these guys. Yeah.
Oh yeah, this is, we worked with him. I mean, this is John's, the same guy is up here, EA8. That's okay. This is John. We met with him at Hamside. This is Steve, who you worked with, who has the Air Spy. This is Clint. This is Holger. This is Peter, who's a Monday guy. This is this is Tom second. This is John Ackerman, who's part of here's my 2 sites, KFS and KPH.
Okay, so what is your connection to those 2 sites? I'm
a volunteer. I kind of approached them about, I don't know, 6 years ago and said, geez, you got this great receive site, but it only gets used on Saturdays for a few things. Would you be interested in putting in making your antennas and listening available 24/7? Right. And they said, yes, we've been looking for you.
So you have access to KPH also.
I can go out there, any Saturday, or if there
do you have a 888 running a KPH yet? You haven't?
No, I don't. And once one of these 5 888s is destined to go out there.
Good.
So that's kind of my project of the week, is to put the external GPS adapter and switch on them.
Okay.
And Q.
Okay. And next time I come up there, I'm going to want to tour one of these sites.
Well, I can any Saturday any Saturday I can take you out to KPH, and
Okay.
almost any day I can take you over to KFS because it's right near here, and I have.
Cool.
But
Right.
KFS isn't nearly as interesting as KPH, and actually, it's really, and this is true for anybody who's listening here. If you're in this area, contact me. I'd be happy to meet with you, and we could go out to KPH. And really, the receive site is somewhat interesting, but the transmit site is a lot more interesting, and it's not open to the public. But I could take you over there, and you can see their banks of old Collins 50 kilowatt.
I've seen in YouTube videos.
Yeah, you go in there, on a Saturday afternoon, and all the mercury vapors things are flashing away as they keep. It's quite it's quite an installation.
Oh, mercury vapor. They let them use that, huh?
Okay. Well, that's still there. It's a legacy. This is a historical living history museum.
Yeah.
So that's what's. So I'm an official volunteer. So for the Park Service, and what I got out of it is a shirt with my name on it. And
Okay.
Park
So
Service
the /Qs are all sites that are using my radio.
Yes, that's been the convention is that the /Qs. Not everybody is. I don't know. Yeah, the ones that I've set up. There are more sites using triple eights than are on this list.
Okay.
So there are 13 sites running my Whisper Demon 3.1. That doesn't mean they're running a triple eights, but there's no real reason for anybody to use 3.1 except to talk to a triple eight or a Air Spy or other device.
Okay.
Say, I also want to mention the AC0G and the KV0S are both Q.
Oh, there's two. Yeah, there's two. Is that you, Dave?
This is Dave, KV0S.
Yeah, okay. I didn't. Are you running Whisper Demon?
Not Whisper Demon, but I'm running Phil's code.
Eventually, I would like to know just how many people are using my code. I don't always get feedback.
Okay.
So those two, I mean, we're right there with the rest of the top stations. And when we switched, I switched from a red battalion. It moved me up, 25, 30 places in the list.
Really?
Mm-hmm.
Yeah.
Same antenna and everything?
I'm sorry. What were you using before? What?
The red battalion with Pavel's code.
Yeah. And then what have you moved from?
I went to Phil's K9Q radio.
But how are you running? How are you posting the spots from his K9Q?
So I'm using his Whisper decoder, and then I have a.
You have a script that pulls out his decodes from his.
Okay.
Yes.
Oh,
and then
okay.
I just use a script that uploads it every 10 minutes.
Okay.
Okay. Is that what Dave's doing too?
Michael, AC0G and KV0S.
Okay.
We both do that.
Well, okay. Well, yeah. Well, that's the smallest subset of what Whisper Demon does with a.
Right.
Okay, it's a. But I don't. That's great. I'm glad you're using it, and yeah. So you should be using MBPT uploads, right? The block file uploads. If you're going to upload every 10 minutes, you don't want to do one spot at a time.
No, we do block.
Yeah, you have block uploads. Yes. Yeah.
But, and those two stations, the 20 and 21 on your list, were about 15 miles apart.
Well, they look like they have very similar characteristics.
Right.
They don't have the same antennas and
different antennas, but but the radio is the same.
Uh-huh. Well, as you can see, this is KPH and KFS actually have the same
Yes.
KFS has four antennas, so it will pick up some more stuff than KPH, because at certain times of the day the big beam antenna is putting out to over the
Okay,
Pacific.
I found this site. I'm scrolling through it too. Well, there's a lot of people.
Well, yeah. You're talking about the rocks, Whisper Rocks.
Yeah. Okay.
Oh,
yeah.
I'm just. Oh yeah. Well, here's Phil himself. Here's his site. I'm trying to, but almost all of these people down here are running Whisper Demon on their. Here, this is Fernando, who's down in Brasilia, who I've helped with get him set up. He's maybe ordering a 888. This is this is Peter. So okay, he's near you guys. Same. You can do things sort by locator. I mean, it helps to.
Yes.
Okay, because there's so much of the
And now groups people were reasonably close.
Yeah, well, you need to look at the people in the same area to get a realistic comparison.
Yeah.
So so you can see that that Peter, who's relatively near you, you see he's getting 41,000 spots from his Kiwi.
Right.
And 1,600 uniques. He's a Whisper Demon site, and then these are so you're getting 30. You're getting 28,000 spots for 24 hours. That's very good numbers.
Yes.
But we have one of the ways we're studying. Here's John down in Costa Rica. He has a hard time receiving because he's got an electric fence right next to his antenna. So,
I mean, ultimately, it comes down to antennas and noise level, right?
Yes.
Mostly it's here's of course here I am in Maui.
Yeah.
So you have to you have to look at things at these kind of top spotter things. If you can use different kinds of metrics. So if you do it by distance, whoa, this is Phil's favorite metric, because he comes out on top. Well, he's down there in Tasmania.
Right.
Yeah, and
UK7 is what?
He's Tasmania.
Tasmania. Okay, I was trying to figure out which states were what numbers. Okay.
Yeah, this is a guy up by Melbourne. Phil's
5. I know. Well, 5 is Adelaide.
Adelaide. Okay. Right? Yeah. Okay. Anyway, Phil is always kind of competing with him. So Phil is happy that his when he's.
There's some ZLs. Okay.
Yeah, there's some. Yeah, this is one. This is Martin, one of the Whisper Demon users. He's got a pair of Kiwis. By distance, you see that Fernando is way down the list in terms of uniques, but in terms of distance, he's down there in the southern hemisphere.
Right.
So he does very well. So if you look at somebody who does pretty well comparatively, as you look at Tom, he's doing pretty well for being on the East Coast.
They're not bad being out in the middle of the ocean. Yeah.
Yeah. So anyway, so each one of these metrics is. Here's the wall of shame. The people who post up there. There's the people who post up duplicates to JTX.
When you say duplicates, what do you mean? The
spot, the time, the transmit call sign, and the frequency are the same, and they're entered twice into the.
By the same reporter.
By the same reporter reports the same spot twice.
Well, that's just a software bug.
It's somebody who's running 2 instances of JTX on 2 antennas.
Yeah.
And so they're just
2 antennas. Well, I mean, that should be okay.
Probably.
You just want to have something that merges them. That's all.
Well, that's what one of the things Whisper Demon does, is it merges and picks the best of them, so that you don't deliver these bogus spots that
Because
basically
eventually you're going to do that at KFS, right? Don't you want to have one of these on each antenna?
they already are there. That's how they're running.
Oh,
I basically, but eventually I want to put a AAA, replace no longer use the Kiwis, but have a AAA on each of the 4 antennas,
right?
And then free the Kiwis so that they can be used for general purpose listening, which that's because they're good for that. But Phil has a whole bunch of other, this is, I mean, there's a whole bunch of he's got all of these different. Here's the top beacons. Let's see who's doing on. See who.
The Wi-Fi network. You might want to check the connection settings in the Google Home app.
I think that's a.
That was Dave.
Yes, but anyway, here this shows you. That's okay, no problem. It's so this is the top transmit sites, and so this is the guy Bill who I've been talking to. Who's he's right now he's transmitting everything on every band. He has a transmitter and inverted V dipole, half of wavelength above Marsh in Florida, for each of the Whisper.
5 watts is a relatively high amount of power for Whisper.
Yes, it is.
Yeah, it's relatively high. Yeah,
it's relatively high. So he pops up as number 1, and he's building a set of parallel ones to transmit 4W.
Yeah.
So that's great. I mean, I wish everybody would do that. So we had lots of good sites. I don't know that I don't know how stable his transmitters are, which is that's I don't think that they're GPS stabilized. So they're they're a questionable utility for radio research purposes.
Where is 8P6? I don't recognize that one.
Which one? HP6.
Yeah, 8.
This is
Where's that?
This is down in the Caribbean.
Okay.
Okay, this is I forget now, but it's a Caribbean island.
It's Caribbean. All right.
Okay, it's most of these are recognizable. I don't know a lot of these people because I've been focused so on receiving until recently that I don't know many of the people who are transmitting. This is fundamentally, this is where I go look for if I want to see how well my receive site's doing. I'll go up here and say any transmitter KFS for the last 1 hour, all bands, all modes, and do a search. And I've logged 2,100 spots from KFS, and this is a very crude metric. But you can see here's a map showing all of the the bands and so on. So you can see. I just look here to make sure that all the bands, that everything is active, that all the Kiwis are running, and so on.
Not much on 160.
No, there's not much on 160. Well, the problem is in part because the KFS really doesn't have a 160 antenna.
Yeah, I think the filter cuts out.
Yeah, they got high pass filters that are downstairs where I can't control. So if you want to look at a better view for 160, but not even so, not a great one, KFS has a separate loop antenna. And you see it's roughly the same number of spots. And now this is only one TCI 530.
Yeah.
Okay. Whereas the other one is a merge of 4 antennas at KFS.
I'd be curious to see how those antennas at KFS compare. They're supposed to be one and a directional one. It'd be interesting to see.
You can do it. There's ways to do it. You can actually get the antenna patterns from pages here in he has what are called charts, and you can look at save charts. Let's see, where are these things? Save charts.
Yeah, I would just be interested to see how it skews.
You can Let's see, stats. I forget now. I think he's well, I haven't been here. I don't use it. I don't use it very much, but you can actually he'll generate a polar chart showing you the direction and intensity and distance of the spots you've had in the last 24 hours.
Yeah.
So from that you can get a pretty good idea of your antenna pattern, especially if you compare it against another antenna. So there's this is all stuff that Phil does, and I encourage all of the data that he's pulling out here is coming from the Whisper Daemon database, and not directly from WhisperNet, because
yeah. So you are listed on 60 meters, but there's very little activity there.
On 60?
Yeah, I see 3 spots. I think you saw.
Yeah, well, yeah. If you go down to 60, okay. Wait a second. 60
There's
meters.
much
There we go.
activity there.
Well, just pull out for the last 24 hours. Okay. That's all that we've gotten from on the West Coast. One guy and okay. So if we go back and see what happens let's try the East Coast. Where's I don't see Tom Paratori here. Let's see, where is EA8? Oh, I don't have, okay, that's EA8
Is there a common worldwide frequency for 60 meters, or are they?
There's a set of 5 frequencies. It's
yeah.
Here's the 60 meter. Here's from the spots reported in the last 24 hours from. So you can see almost all the activity. I'm sorry, why can't I zoom?
But you are listening to all of them, right?
Yes. Well, most of these sites, most of the Whisper Daemon sites are listening to all, either 80 through 10, and this even includes 22 meters. So one of the ISM band, they also has a few Whisper transmitters.
Yeah, I heard about that. Is there actually activity? Do you show that?
Yeah, well, you can go and look. Let's go back here and look at 22 meters. Nothing in the last 24 hours. Now BFK may not be listening. I'm not sure if he's configured. Let's see. Let's go to
KFS is listening, right?
KFS, but at KFS, we're not going to hear anything from Europe. So there's 2 guys, or I guess there's 3 guys here. I don't understand why.
There we go. Okay, that's 22 meters.
Yeah, that's I don't.
So you heard some from the east. That's pretty good.
Yeah, okay, so I mean those are 2 milliwatts transmitters.
Not bad.
2 milliwatt effective radiated power or something, or some. If we go,
I told you about the buoys we've been putting out in the Pacific, right?
Yes, I in fact I even noticed them long before, several years ago. I noticed them and wondered.
Okay, yeah. Well, we're going to probably do another one, so it would be interesting to see. I mean, not everybody's listening everywhere. We should.
Well, we are definitely okay. So, okay, BFK, he apparently isn't listening on 22 meters. OE9 GHHV/Q. I know I set him up.
Yeah, we're talking about another one. So
I set up the Q to definitely listen, because with your code, it costs us virtually nothing to add additional.
It costs you nothing.
So you can take a look. You can see, well, there's only those signals, those 2 milliwatt signals are making it to Austria.
And that's 22 meters.
That's 22 meters to Austria. That's. How do you like that?
Is used for ISM stuff, like what, badge card readers and stuff like that.
Yeah. I don't
That's
know.
pretty wild.
Isn't that wild? Well, I had this idea. I have a friend who's a apiarist, I guess you call them. It's interested in bees, and he'd like to monitor bees, his beehives, but they're distributed all over the place, out in fields, long distance away.
Yeah.
So my idea is to put a little solar powered Whisper transmitter on 22 meters, and feed his data as payload into the Whisper packets, and use just the way the balloon guys do do a 2-packet sequence.
Right. Yeah, we've done
Do
that.
do the same thing for the beehive monitoring.
Yeah.
And so it could be deployed worldwide. It would be unlicensed, so no licensing problems. And the receive sites are already in place. We've got we've got all of these Whisper sites listening on 22 meters and recording the spots to the database. So that's one of my side projects with my oldest, my guru, who worked at Linkabit down there in San Diego. He taught me back in the 80s. Steve Treadwell taught me everything I've ever learned about computer programming, really. So anyway, he lives in rural England. He's so anyway, that's that's some of the gives you some insights of how you might use Whisper and this network in ways that one wouldn't have thought originally.
Yeah.
Now this is all data that's derived from the WhisperNet reports. We have another layer of data that we output for that Whisper sites upload to the Whisper Daemon servers, and that includes the background noise levels. And that's where I need your AGC be able to fix your AGC.
Well, I think I got my noise. I think I it's funny how you find like latent bugs in code that that are there until you really look for them. Like for example, my noise estimation algorithm, I was only looking at every other bin.
Oh,
so I was double incrementing a loop.
Looking
every other bin.
Well, that's
stuff like that. It kind of worked anyway, but
Well, one of the I would really like to do that, because I think that your noise level calculations, I'd like to include that, add that as a supplement to the ones we're doing from the
I would
information.
like to compare them. I would like to compare them. There's no ideal way to do this.
So when you provide the mechanism to fix the AGC and adjust it, I'll adjust. I'll if I can measure the average signal level, I can periodically adjust the AGC value, and then I can that will allow me to have a relatively calibrated background noise level values, and
I was surprised when we did this checks on the bench, and the level coming out of my well, actually the level at the A to D output is in dB FS was remarkably close to the input RF level in dBm.
That's a nice correspondence. So we said, we're not so dependent upon, because there's so many other factors in terms of antenna factor, efficiencies and so on, distribution networks and so on. I do make provisions in Whisper Daemon that the operator can configure, adjust for known, a gain and loss in the distribution system. So to kind of get them in a rough ballpark, but in fact we also make those adjustments by band, so you can compensate. The Kiwi has the Kiwi's low pass filter has about a 3 dB bump at 28 megahertz, which is not compensated for in their
you mean an increase?
Increase, yes, there's an increase.
Is that, and then does it fall off faster?
I've never really looked at the filter characteristics, but if you put in a constant signal and vary it by frequency, as you get, the output level will go up to about 28 megahertz, and then of course it drops as the
that's actually not bad if it improves the noise figure at the high end, but Yeah.
doesn't prove it enough. We still need the shelving filter, which is
Right,
I've told on the
and
way
it
here.
doesn't cut off fast enough. I mean, the California Highway Patrol alias is
Well,
down on TV band.
I'll send you when Paul has said he shipped me the beacon blasters and some of his low pass filters. He really does. He wants. In fact, somebody mentioned an interest in having one of those low pass filters from Turn Island Systems. Paul doesn't have time even to operate a mailing thing. So I told them include them all, and if anybody asks for them, I'll package them up and mail them from here. So I'll mail one from you probably later this week. I'll get your mailing address and send you one because so you'll probably, well, in your case maybe you have enough noise that even on 10 meters you don't really need any gain.
Well, I'm gonna find out.
But you'll find out. I mean, you connect up your antenna and look at the noise level on 10 meters and see what happens. If it goes up, then there's nothing, you don't need any more gain.
I've been seeing a lot of 10-meter activity during the day sometimes lately. So
yeah, well, there's the 10 meters is really. And the bands are open pretty well during the day. So
yes, they are.
Okay, so I think we've burned enough. I hope you haven't worn out your vocal cords here. So I really appreciate it, and I'm glad. I hope I've given you a few things to cogitate on.
Okay, yeah.
I think we're at the point though where I am ready to declare on the Whisper-DM forum that 3.1 and 888 are ready to go. They will require some may require hand holding to get.
My only concern is getting a lot of people to get the 888s and then discover we have a problem. That's my biggest concern.
I don't think we've gotten to. I think we've got enough samples. I think we've don't you I don't know how long do you want to? How long do we? I mean, how long do we do? How long do we do? I mean, it's going to be. I'm going to declare it as beta. It's not going to be.
Well, I would feel a little better for now, just running at half sample rate, with filters if possible.
Yes, well, that's why. I'll have the filters, and I'll say that you need to run it. I don't think we can run it at 133 or whatever it is. It's I don't think.
I was doing that. I could listen to the CHP as another set of FM channels, but I got a little uneasy after you had your problems.
Yeah, well, I don't think. That seems that may have been the source of my overheating problems. Is that that I was running your original code, which I think your code defaulted to 122.
That's right, and I changed the default.
Yeah, you changed the default, and I think that may have been a week of 132 mega samples might have been the precursor to my.
I was doing 129.6.
Whatever you choose. Yeah.
Well, I've been using 65.536 because it moves the California Highway Patrol repeater on 39 off of WWV on 25 before it was always directly on top. So.
Well, it'll be interesting to see if Paul's filter is good enough to allow you to go back to full sample rate. So but anyway, we do have we have beacon blasters going down and a 888 going down to the Antarctic.
Oh, good.
You didn't. You may not have. You're not.
No,
probably
we're in Antarctica.
This is the German Antarctic Research Station.
Okay, yeah, that one. Yeah,
TP0 TPL. They've been on air using red Patajas. That site is managed by Professor Michael Harje at the University of Bremen. Excuse me. We met with him. He was the organizer of that session at Friedrichshafen. He was one of the two organizers of it. And he is also the responsible scientist for the German Radio Club, the whatever their name is,
Right.
who sponsor this site, transmit and receive site that's down at South Antarctica, and they've had a red pitaya down there for several years, and they wanted to upgrade, and and so Michael was very intrigued by the beacon blaster, and he has a single transmit antenna. So Paul is and he has the German Radio Club has agreed to sponsor the purchase it. So he's purchased a beacon blaster, which I'm going to stage and ship out hopefully later this week. To be shipped, it needs to get to Bremen by mid-September because that's when they load the ship that heads down to the south.
Yeah, there's a narrow window there. Yeah.
Yeah, so they go down, and then Michael will be flying down there to be on site in January, which is when he would set it up. So he's also ordered a 888 and Orange Pi, and I warned him about the Orange Pi as a that it's problematic. So I said,
I wouldn't scrimp on hardware here. You know, buy all the hardware you need with some spares. So
yeah,
you know,
well,
once it's there, they can't really.
Yeah, they can't. Yeah, so that's why. So I just said, I think you ought to take a Think Center or some more robust
yes
computer than an Orange Pi.
Now I have inquired about South Pole because I know somebody who's there now. We've been chatting. And he says that, it's possible, but it's extremely bureaucratic, and I don't even know where to start to get something.
So we're gonna have remote access. It's going to be just like Holger's. We have a site, a receive and potentially transmit site up in Greenland, up in northern the VK.
Well, that'd be interesting. Yeah.
So that one is already set up and working. We've had that up.
Would be interesting.
Yeah. We're getting the you don't need to be looking at this anymore. So we'll do that. In addition, one of the HAMSI members, Gareth, who is was a colleague of Phil's of Nathaniel when he was at the University New Jersey Institute of Technology. Gareth works with Ryan Tolboom. So Gareth was last week participated in this call and was going to go talk to Ryan about the Whispered D enhancements. But Gareth and Nathaniel have also applied to the NSF for a grant to deploy, I think, 3 Whisper stations down in south in Antarctica. And now these would be at American sites. They were not at the German site, so they'd be 3 additional.
Well, I don't know what I mean, you don't know which ones.
I don't know. I don't know the details of their proposal or the status of it. But they were discussing that, and I know that it's seems like a real possibility.
I think the only problem would be antennas. If they don't already have antennas, that would be the problem.
Yeah, so that would be that would certainly that's the big challenge in the Arctic environments.
Right.
Now, if you're up on the ice, you can put a loop on the ground for receiving and do really quite well. That's
I mean the ground doesn't conduct. Yeah. So.
Yeah, and so it doesn't really bother it. I think you may even be able to do transmitting. I mean, I don't know how much.
I don't know. I mean, there might be certain receiving would certainly be bureaucratically easier. When you transmit, you have to worry about all sorts of possible.
There's the EMI things and so on. So, but anyway. So Nathaniel and Gareth is a NSF project entirely separate from this NSF funded project we're working on. The Personal Weather Station project is this Tangerine Clementine project is a part of a part of an NSF funded project for the Personal Weather Station. So this is a South America thing is a separate, not yet funded NSF project. But you know, well, I have bigger plans than that, but I won't. We've been talking for a long time now, so
Yeah.
I think we should maybe go off and
Yeah, I need to go eat. Cats
yeah,
trying to get my attention.
to do something else. Anyway, thanks for all your work. I think I'm, you know,
sure.
I think that now that I have low pass filters and I think we have fairly stable code at. I'm running this code at KFS, Holgers. I don't see where else I have a 888 under my command. Glenn is running it. In Colorado. Tom Paratori is running it. Steve Sykes at KD2OM. We have a lot of beta sites for this code. So I think you should feel a fair amount of confidence. I think it would be a good time once you check in that one change of mine, WD report change. Once you do that, then I'll feel comfortable that we're not going to.
Where did you mail to me?
I emailed it to you as an attachment to an email.
I'm gonna have to start learning better how to use GitHub and how to do merge pull requests and stuff like that.
All you have to do, you have to do is just copy it into your directory and do a get commit and get push, and then it'll be.
Yeah.
That I barely know how to use GitHub. It's but it is. It's a very amazingly useful tool. It's amazingly useful.
Once you learn it.
Yeah. Well, my son is responsible for GitHub at Apple. So when I run into GitHub questions, I chat him up. So it's anyway. Enough. Okay. Well, I think if we lost everybody else, there's some people lurking. Dave Larson's still there.
Yes, I'm still here. I had to go and help. I have to take care of my wife at certain times, and I had to leave for that.
I'm surprised you're still hanging out. So it's
well, I was coming down here to close down the ham shack.
Okay.
You guys were still on.
Well, this is one of the times we get to actually chat. Most of the times we're typing in chat windows.
If you have a moment, just got a quick question for Phil.
Yeah.
Yeah.
Hi,
I'm
Phil.
getting hungry.
Nice to keep. I'll keep it short. So I read on the internet that you can use your code plus PA3FWM server to make a web SDR. Do you know anyone's actually done that yet?
No, I mean, I would love to see somebody do that, but I don't have any experience with that code. I wouldn't know how to do the integration, but I'd love to have somebody do that.
It would be a marvel.
So I'm sorry.
Please, yes. If we're volunteering, we're
this could be a large scale web SDR. Hundreds of users.
Okay, all right. I'll follow up on it. Thanks so much, Phil.
Great, thank you.
Thank you.
All right, I'll see you guys.
Okay, take care, Phil.
Good night.
Take care, Dave.
Yep.
Who else we have? Jonathan that's lurking, but anyway, and Dave. So good night, all.
73.
Wow.